Let's look a little bit more at effective stress and what happens when there's effective stress. So remember, we talked before about how we have grains of porous medium, and then within those grains, of course, we have water in a saturated case. And so we have a pore pressure here, which we related to the head, so we can think of this as head or pore pressure. And then when that pore pressure changes, we said that we had a change in the effective stress. So the effective stress is the stress of these grains pushing together. And we ended up with a balance where we said that the effective stress was the negative of the pore pressure, change in pore pressure, which we also could say is the change in the head. The change in the head, which we find simply by multiplying times the specific weight of water. So when the pore pressure decreases, the effective stress increases. So what happens when that effective stress increases? Well, it depends on where that's happening, what medium we're in. So we have to talk about the compressibility of the medium. The more compressible the medium, the bigger deal this is going to be. All right? So we're going to make a definition, and so we're going to call compressibility we're going to call that alpha, and we're going to define it as the change in thicknesses. So if we have some unit thickness of material that we call B, so we have alpha is the compressibility, and B naught is the initial thickness of the layer, and dB is the change in thickness of the layer. The change in the effective stress. Okay, so the compressibility, alpha, is showing us how much the thickness changes relative to the change in the effective stress. All right, so if we look at some typical values, of alpha, we might find that sound rock versus sand versus clay versus water has ranges, and we're gonna give this in units of meters squared per Newton. It ranges between 10 to the minus 9th to 10 to the minus 10th. Let's make that 10 to the minus 11th for sound rock. And for sand, we have 10 to the minus 7th to 10 to the minus 9th. And for clay, 10 to the minus 6th to 10 to the minus 8th. And then water has a compressibility about 4.4 times 10 to the minus 10th. Okay, so you can see that water is very incompressible. It has a compressibility on the order of a sound rock, like a granite or something that's not very fractured. Sand isn't terribly compressible. Clay, however, you can see is orders of magnitude more compressible than sand and sound rock. Right? So we would expect that this alpha value, the change in thickness with respect to effective stress, is going to be much, much greater in a clay than it would be in a sound rock.